Hello students, I am Shaji Tandon from Crack Chemistry. Today I am here with the class 12 topic. The name of the topic is Biomolecules Part 2. In today's session I'll discuss about the structure of glucose and I'll give you some very easy and simple tricks to learn various chemical reactions within minutes. So before starting, I just want to remind you to subscribe my channel for getting information about further important uploads. Like this video in case if you have liked it and share the video with your friends. So now let's see what we will study today. So as I told you that we are discussing the structure of glucose today. So children, first I want to mention some important points regarding glucose. Glucose is an aldohexose. So how you can learn this point? Aldohexose is made up of two words. One word is aldo. So aldo represents the presence of functional group. So glucose has aldehydic functional group in it. So due to the presence of aldehydic functional group, it is known as aldo, and hexose represents 6 carbon atoms are there. So hexose means 6 carbon atoms are present, and aldo represents aldehydic functional group is there. So aldehydic functional group. So because of the presence of aldehydic functional group and 6 carbon atoms, it is known as aldohexose, and children, it is also known as dextrose. Then second important point is that it is the monomer of many larger carbohydrates like starch, cellulose, etc. Third point is that it is probably the most important organic compound on earth. And final point is that it was assigned the structure which I am going to discuss in my next slide. So this is structure. Glucose was assigned on the basis of various reactions. So after discussing the structure, I discuss various reactions after which the glucose was assigned this structure, and side by side I will tell you very important tricks to learn these reactions quickly within minutes. So now I am going to write the structure of glucose which it was assigned. So glucose was assigned following a structure. So I am writing the structure here, CHO. Just now we have mentioned that it has an aldehydic functional group. After that it has CHOH whole 4. So these 4 carbon atoms, they have the similar groups attached to it, and the last carbon atom has CH2OH. So this was the structure of glucose. So I am writing here, this is the structure of glucose which it was assigned after various chemical reactions. So what are these various chemical reactions? We will discuss one by one. So first point, children, you have studied in your previous class that how we find out molecular formula. For finding out molecular formula, we calculate with the help of experiments, we find out the number of elements, the type of elements present in it. After that, we find out percentage of these elements, and finally we calculate the molecular formula. So its molecular formula was found to be C6H12O6. Then this is the point number 1. After that, once its molecular formula was found to be C6H12O6, scientists had to probe that how these 6 carbon atoms are arranged. So for that I am discussing the next reaction. Next reaction is that when glucose was heated with HI, it formed N-hexane. So children, I am writing the reaction of glucose with HI. So again I will write the structure of glucose which I have discussed just now. So aldehydic group. After that we have CHOH whole 4. CH2OH. So this is the structure of glucose. So when this glucose was heated with HI, we got N-hexane. So children, N-hexane has all the 6 carbon atoms attached in a straight line. So CH3, CH2. So here we will have 4 CH2, 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 CH2. Then 4 CH2, after that we have CH3. 3. So children, this is the structure of N-hexane. So we can see here that since in case of N-hexane, all the 6 carbon atoms, they are linked in a straight chain. So it indicates that in glucose also all the 6 carbon atom must be linked in a straight chain. So now on the basis of this chemical reaction, we have proved that in case of glucose all the 6 carbon atoms are present in the straight chain. So how you will learn this reaction? Simply you just write the structure of glucose. After that you will write the 6 carbon atoms which are attached to each other in a straight chain. Then next reaction, glucose reacts with hydroxylamine. Children, hydroxylamine you have studied in the chapter aldehydes and ketones. So hydroxylamine has the formula NH2OH. So glucose reacts with hydroxylamine to form an oxime. So in that chapter you have heard that, you have studied that carbonyl compounds, this is the characteristics of carbonyl compound, that they react with hydroxylamine and they form oxime. And similarly the carbonyl compounds, they react with HC and hydrogen cyanide and form cyanohydrin. So as glucose is giving both the reactions, so it indicates, it confirms the presence of carbonyl group in glucose. So this point also we can learn like this. So now I am writing the reactions of glucose with hydroxylamine and hydrogen cyanide. So first I'll write the structure of glucose here, CHO, CHOH whole 4, CH2OH. So this is glucose. Then I am writing its reaction with hydroxylamine. Hydroxylamine is NH2OH. So children, how to learn this reaction with hydroxylamine? I would like to make a small change here. So what I will do, I will not write CHO like this. I will write CHO in a little bit different way. Similarly, hydroxylamine also I will like to write in a different way. So how I will write, just see. So I am going to write here CH. H I'll write here, double bond O, plus NH2OH. We will write here NH2OH. So NH2OH is hydroxylamine, which I am writing like this. So if I write like this, it will become very easy for you to learn it. So from here you can see that a molecule of water is eliminated. So I am showing you here. From here a molecule of water is eliminated and the remaining things you can write as it is. So I am just writing here CH. After that you can see water is eliminated. What is left here? CH double bond N OH. After that remaining things will remain as it is, CHOH whole 4. CH2OH. So what is the name of the product here? The product formed is an oxime. So product form is an oxime. And this is hydroxylamine, as I told you. So always remember that only the carbonyl compounds, they react with hydroxylamine and they form oxime. This reaction you have studied in the chapter aldehydes and ketones. Then I would like to write the next reaction, reaction of glucose with hydrogen cyanide in the next slide. So again I am writing the structure of glucose here. So now by this slide the structure of glucose you must have learned it. CHO, CHOH whole 4. CH2OH. On arrow I am writing SCN. So children, all the carbonyl compounds, they react with SCN and they form cyanohydrin. So what is the product here? The product form will be CHOH, CN. Then we have CHOH whole 4 CH2OH. So the name of the product here which is formed is cyanohydrin. So I'm writing the name of the product. This is called as glucose cyanohydrin. So this is glucose cyanohydrin. Now, I would like to tell you how to learn this reaction. Children, if there's a logic, the reaction becomes easy for you to learn. So I am writing the structure of carbonyl compound here. So children, carbonyl compound, this is the carbonyl group. As oxygen atom is more electronegative than carbon, it will acquire a partial negative charge, and the carbon will acquire a partial positive charge. Now I am talking about SCN. Children, SCN, hydrogen is having the positive charge and CN is having the negative charge. So hydrogen is having positive charge, CN is having negative charge. So what will happen? This H will attach. This H will attach itself on the O, and this CN will attach itself on this C, which acquire the negative charge. So rest of the things will remain as it is. So by this technique or by this trick you can learn this reaction easily. So here I have shown you how to learn this reaction. I gave you a very simple and interesting trick. So that this trick I am writing like this, so it will become easy for you to learn this. Then next reaction. Children, glucose gets oxidized to 6 carbon atoms. Acid. The name of that acid is gluconic acid. It's a carboxylic acid. So glucose on reaction with a mild oxidizing agent like bromine water. So children, bromine water is a mild oxidizing agent. So when glucose is treated with a mild oxidizing agent like bromine water, it is oxidized to a 6 carbon carboxylic acid. The name of that acid is gluconic acid. So always remember one point, that only aldehyde can be oxidized by a very weak or mild oxidizing agent like bromine water. But if we have some other functional groups, they can't be oxidized like alcohols. They can't be oxidized by weak oxidizing agent. So let me write the reaction again. Again I am going to write the structure of glucose here. CHO, CHOH whole 4, CH2OH. So children, this is the structure of glucose. What I'll do, this on treatment with bromine water. When it is treated with bromine water, so children always remember that bromine water is a mild oxidizing agent. What will happen? It will oxidize this aldehyde group into the carboxylic group. So CHO will be converted into COOH. Then remaining things will remain as it is. CHOH whole 4, CH2OH. So we have seen that bromine water affects only aldehydic functional group. So I'm just writing the name of this acid. This acid is gluconic acid. So now again I would like to tell you a very simple trick here. As I told you, CHO, always remember carbonyl group. Children, carbonyl groups is present in, this is a carbonyl group. So carbonyl group is present and you will find this carbonyl group in aldehyde. You will find this carbonyl group in ketones also. And you will find this carbonyl group in the carboxylic acid also. So, children, only aldehydes, when they react with bromine water, they are converted into carboxylic acid. So, I am just writing here aldehydes. Aldehydes can be oxidized easily to carboxylic acids. By weak oxidizing agents like bromine water. So here in this reaction you can see that glucose can be oxidized to 6 carbon atoms. The name of that 6 carbon atom acid is gluconic acid. So what does it mean? It indicates that the carbonyl group which is present in case of in the case of glucose is aldehydic group. So we are coming a stepwise. In the first reaction in the first step we have seen the molecular formula of glucose. Then in the second step we have seen that all the 6 carbon atoms are present in the form of a straight chain by reaction with Hi. Then in the third reaction we have seen that the glucose on reaction with NH2OH it forms an oxime, and on reaction with SCN it forms a cyanohydrin, the reaction which is given only by carbonyl group. So we could prove that it consists of a carbonyl group, and in this reaction we have proved that the carbonyl group which we were talking about is an aldehydic group. So now I just want to mention the next reaction, children. Next reaction, acetylation of glucose with acetic anhydride. So children, acetylation means introduction of COCH3 group. So this point you have to remember, because sometimes they ask the question, write acetylation. So what is acetylation? Acetylation is the introduction of COCH3 group. So I'm just writing here what is acetylation. Acetylation is the introduction of COCH3 group. So this COCH3 group introduction is called as acetylation. So when glucose is acetylated with acetic anhydride, it gives glucose pentaacetate. Children, remember one thing, the alcoholic group which is present in glucose combines with acetic anhydride and forms pentaacetate, because alcoholic group can be acetylated with the acetic anhydride. So what does this reaction proves? This reaction proves that as we are getting pentaacetate with acetic anhydride, it simply confirms the presence of 5 OH groups. So, and one more point, all the 5 OH groups, remember one point, that if all the 5 OH groups are present on different carbon atoms, then only it be a stable compound. If a carbon atom consists of more than one OH group, then the compound won't be stable. So now I would like to write the reaction here. I'm writing the formula of structure of glucose, CHO, CHOH whole 4, CH2OH. So this is glucose. Then I am writing here on arrow, I am writing acetic anhydride. So it gives 5 pentaacetate derivatives. So I am writing here CHO. Then you will get CHO, C double bond O CH3. So you can see here, children, then whole 4. Then finally you will get CH2O, C double bond O, CH3. So children, you can see here that H of CHOH, this H of CHOH has been replaced by OCOCH3 group. So this is called as acetylation. Acetylation means replacement of hydrogen of alcohol, or in case of amines you will also study. So replacement of hydrogen of alcohol by an acetyl group. Acetyl group is COCH3 group. is called as acetylation. So we have seen that when glucose was treated with acetic anhydride, we got a pentaacetate derivative. It indicates the presence of 5-OH group in glucose. So now one more point I would like to mention here in the next slide. We saw that this glucose pentaacetate is a stable compound. So I am writing here glucose pentaacetate is a stable compound. So children, always remember that if a compound is stable, it means all the 5-OH groups are present on the different carbon atoms. If more than one functional groups are present on the same carbon atom, the compound is never stable. So I am just writing here, since it is a stable compound, since it is a stable compound, I am talking about glucose pentaacetate. Since it is a stable compound, it means all the 5-OH groups are present on different carbon atoms. So children, I hope this point is clear to you. Glucose pentaacetate, it is a stable compound, and since it is a stable compound, it indicates that all the 5-OH groups are present on different atoms. Now, another important reaction is that on oxidation with nitric acid, glucose forms a dicarboxylic acid, and the name of that dicarboxylic acid is a saccharic acid. So glucose forms saccharic acid on oxidation with nitric acid, as well as gluconic acid forms a dicarboxylic acid, same acid on oxidation with nitric acid. So children, remember one thing, carboxylic acid. On oxidation, carboxylic acid is given by aldehyde as well as primary alcohol. But remember one thing, aldehyde can be oxidized to carboxylic acid by a very weak oxidizing agent like bromine water. But primary alcoholic group cannot be oxidized by a weak oxidizing agent. So when we have taken the strong oxidizing agent, so what will happen to glucose? First I am writing the reaction of glucose here, CHO, CHOH whole 4, CH2OH. When it is oxidized, it is oxidized with the strong oxidizing agent. I am talking about the strong oxidizing agent is nitric acid. So on arrow I am writing here nitric acid, HNO3. So children, you know that glucose will give us dicarboxylic acid. Its name is saccharic acid. So CaOOH. Now I am writing the formula of saccharic acid. It's a dicarboxylic acid. So CHO is converted. This CHO is converted into COOH. And this thing will remain as it is. CHOH whole 4. CHOH whole 4. And the CH2OH, which is a primary alcoholic group, will also be oxidized to COOH. So the name of this acid is saccharic acid. I am writing here. This is saccharic acid. So this was glucose. Now children, I am writing here gluconic acid, and gluconic acid we have discussed in a previous slide when glucose was treated with a mild oxidizing agent like bromine water. So we got gluconic acid. So now I am writing gluconic acid. So gluconic acid has the formula COOH, CHOH whole 4, CH2OH. So which acid is this? This is gluconic acid. So when gluconic acid is oxidized with nitric acid, we also get the same product. So what does it indicate? It indicates the presence of a primary alcoholic group in glucose. So I am writing here its name. This is gluconic acid. So I hope children this point is clear to you. But again I would like to mention some points here. As I told you that aldehydic group, I am writing here aldehydic group CHO can be oxidized to carboxylic acid, can be oxidized to carboxylic acids. Can be oxidized to carboxylic acids by a weak oxidizing agent. Like bromine water. But primary alcoholic group primary alcoholic group is CH2OH group. Can't be oxidized to carboxylic acid. By a weak oxidizing agent. So children, this point you have to memorize, you have to keep in your mind so that the reaction will become very easy for you to learn. CHO group can be oxidized by a weak oxidizing agent like bromine water. But primary alcoholic group, which is a CH2OH group, cannot be oxidized to carboxylic acid by a weak oxidizing agent. I am just mentioning here weak oxidizing agent like bromine water. So primary alcoholic group can be oxidized by only a strong oxidizing agent like nitric acid. So this is a very important trick I told you. With the help of this trick, it will become easy for you to learn all these reactions. Then one more point I want to mention here, children. The exact spatial arrangement of different OH groups was given by Fischer. I am talking about the exact spatial arrangement of different OH groups. We have seen that glucose has CHO. After that, we have written CHOH whole 4. But how these 4 OH are arranged, this exact spatial arrangement was given by Fischer after studying its many other properties. So now its correct configuration I am going to write here. So I am just writing the correct configuration of glucose here. So children, CHO, what I will do, I will write the correct configuration in the next slide. So CHO. Now, till now we were writing CHOH whole 4. But now I would like to mention how these 4 OH groups are arranged. So I am writing here HOH. So just see, first H is present on the left hand side, this is the first carbon atom, one carbon atom. This is the second carbon atom. I am not mentioning here. So this carbon atom, but it represents this is a carbon atom. Second carbon atom has OH on the right hand side. And now I am coming on the third carbon atom. The third carbon atom has OH on the left hand side and H on the right hand side. Then remaining two more carbon atoms. Here we have seen this is the first carbon atom, second carbon atom, third carbon atom. Now the remaining, fourth and fifth carbon atoms have the same special arrangement. This is HOH. Here again we will have HOH. CH2OH. So children, this is the arrangement of this structure. First is for glucose. Now I am going to write the structure for, so this, let me write here, this is glucose. This is the structure first. Now I am going to write the structure of gluconic acid. It will remain as it is. So again I am going to write the first carbon atom, children. First carbon atom in case of gluconic acid has COOH group. So this gluconic acid was obtained when glucose was treated with a mild oxidizing agent like bromine water. So what I am writing here, remaining things will remain, remaining groups will remain as it is. So second carbon atom has H on the left hand side, OH on the right hand side. And now the third carbon atom has OH on the left hand side and H on the right hand side. But the remaining fourth and fifth carbon atoms have the same configuration, HOH, HOH. Then, and it will also remain as it is, CH2OH. So what is the name of the acid which we got here? This is the gluconic acid. So I am writing here, this is gluconic acid, structure number 2. Now, I am going to write the structure of saccharic acid, and now children you must be knowing that it is easy for you to write because it will have remaining as it is, but it is a dicarboxylic acid. It consists of 2 COOH group. So here we will have COOH, then we will have HOH. Third carbon atom will have a different special arrangement, H on the right hand side and OH on the left hand side. Then fourth and fifth carbon atom will have exactly same special arrangement, HOH, HOH. And since it is a dicarboxylic acid, saccharic acid is a dicarboxylic acid, here we will also have COOH. So the name of this acid is saccharic acid. So this will be the structure number 3. So saccharic acid. So children, I hope these points are clear to you because in every case I told you a simple trick how to write the reactions. Now children, glucose is correctly named as D plus glucose. I want to mention here what is the correct name of glucose. It is named as D plus glucose. So what does D represent? D represents the configuration, children. This is a very important point. I have seen students getting confusing. So always remember that D before the name of glucose represents configuration and the plus sign represents the dextrorotatory nature of the molecule. Means it is a dextrorotatory compound. So always remember that D and L have no relation with the optical activity of the compound. Capital D and capital L have no relation with the optical activity of the compound. As we have studied in the chapter haloalkanes and haloarenes that the dextrorotatory isomer were written as small d and levorotatory as a small l. But here we are using the word capital D and capital L. So they have no relation with the optical activity of the compound. So now I'll discuss what is the meaning of capital D and capital L notations as follows. I'm going to discuss right now. Children, in the case of carbohydrates, the letter D, always I'm mentioning, I'm just emphasizing on it. This is a capital D because a small d represents the dextrorotatory nature. So in the case of carbohydrates, the letter D or L before the name, they refer to their relation with a particular isomer of glyceraldehyde. So what is glyceraldehyde? Glyceraldehyde contains an asymmetric carbon atom. So children, you are familiar with asymmetric carbon atoms. You have studied in your chapter haloalkanes and haloarenes, but quickly I want to revise. An asymmetric carbon atom is a carbon which is attached to 4 different atoms or group of atoms. So I am writing here the formula of 2 enantiomeric forms of glucose. So, what are enantiomers? These also we have studied in chapter haloalkanes and haloarenes. Enantiomers are the optically active compounds, and enantiomers are the mirror images, non-superimposable mirror images. So now I am just writing the 2 enantiomers of glyceraldehyde. So glyceraldehyde has the structure CHOH. So in this structure, you can see that this OH is present on the right hand side, CH2OH. So this is the plus glyceraldehyde. I am writing here, this is plus glyceraldehyde. Then what about minus glyceraldehyde? Minus glyceraldehyde, only the position of H and OH will be interchanged here. So I am writing here CHO. What will come here on the left hand side? OH will come. OHH. Here we have CH2OH. So what is this? This is minus glyceraldehyde. So I am writing here, this is minus glyceraldehyde. So I hope this point is clear to you. I would like to mention this point once again. I told you that in case of carbohydrates, that letter D or L before their name, they refer to their relation with a particular isomer of glyceraldehyde. So we have seen 2 isomers of glyceraldehyde. One is plus glyceraldehyde. Plus glyceraldehyde, you have CHO. Then H is attached on the left side of the second carbon atom. Children, I am not showing here second carbon atom, but this is a second carbon atom. So on the left side of the second carbon atom, H is present. Right side of the second carbon atom, OH is present, and it represents the plus glyceraldehyde. And in the case of minus glyceraldehyde, the OH and H's position is simply interchanged. So here I would like to write the structure once again. CHO, first carbon atom, then second carbon atom I am not showing here, simply it represents. So this is H present on the left hand side of the second carbon atom, OH present on the right hand side of the second carbon atom, then we have CH2OH. So this isomer is called as plus glyceraldehyde. And what about this now? Here we have CHO. Simply the position of H and OH on the second carbon atom will be interchanged. So OH here, H here, CH2OH. So this will be minus glyceraldehyde. So we can see the structure of plus and minus glyceraldehyde here. Now one more point I want to mention here, children. Plus isomer of glyceraldehyde has D configuration. Always remember this point. Plus isomer of the glyceraldehyde has the D configuration. So what does it mean? Whenever we write the structure of this plus isomer of glyceraldehyde, as I told you that OH group lies on the right hand side. I just want to show you here. This is the OH group lies on the right hand side. So this is the plus isomer of glyceraldehyde, and the plus isomer of the glyceraldehyde has D configuration. So I am writing here it has D configuration. whereas those which are related to minus isomer, they have the L configuration. So I am writing here L configuration before the minus isomer of glyceraldehyde. So this is minus configuration. This is the L configuration. And what I should write here, this is the D configuration. So I am just writing here, this is D configuration. So children, this is a very important point I told you. Glyceraldehyde has two isomers. The one which is having OH on the right side of the second carbon atom is the plus glyceraldehyde. It has the D configuration, and the one which is having OH on the left side of the second carbon atom is the minus glyceraldehyde, and it has the L configuration. So all those compounds which can be chemically correlated to plus isomer of glyceraldehyde are said to have D configuration. Children, now you try to correlate this with glucose. As I told you that you have to compare the glucose with the plus and minus glyceraldehyde. So the compound which can be chemically correlated to the D or plus isomer of glyceraldehyde is said to have D configuration. And I told you in the beginning that glucose is correctly named as D plus glucose. What does D mean? It is related to the plus or D isomer of the glyceraldehyde. And whereas those which can be related to L or minus isomer of glyceraldehyde, they are said to have L configuration. Children, in L isomer, OH group is on the left hand side. I have shown in my previous slides. And now I am correlating this concept to the glucose. So for assigning the configuration of monosaccharides, it is the lowest asymmetric carbon atom is compared. So children, always remember, when we are going to assign whether a monosaccharide is D monosaccharide or L monosaccharide, always we compare the lowest asymmetric carbon atom. So I'm going to show this here. In the case of plus glucose, OH is present on the lowest asymmetric carbon atom is on the right side. So children, let me show you here. I am writing the structure of glucose here. So this is CHO. Now you will be able to write the structure of glucose. The second carbon atom has H on the left hand side, OH on the right hand side. Then the third carbon atom has just reverse, H on the right hand side, OH on the left hand side. But the fourth and fifth carbon atoms will have the same configuration, H, OH. In both the fourth and fifth carbon atom, H on the left hand side, OH on the right hand side. Then finally sixth carbon atom will be CH2OH. So what I said that for assigning the configuration, this is the always lowest asymmetric carbon atom is considered. So what is the lowest asymmetric carbon atom of the glucose? I am just writing here. I am just encircling here. So this is the lowest asymmetric carbon atom of the glucose. This one is the lowest asymmetric carbon atom. This is, I am putting an arrow here. So you have to see. Now I am writing here. One more point I would like to mention here. So this I have written for glucose. I will write its name later on. Then CHO. Children, try to recall, just now I have discussed this with you, CHO, CHOH. Then we have CH2OH. So if you look at the second asymmetric carbon atom, you will see OH is present on the right hand side. So what does it mean? What is its configuration? OH on the right hand side means this is the D. So this is D plus glyceraldehyde. I am writing the name here. This is D plus glyceraldehyde. Now we will compare. We will look at the last asymmetric carbon atom of glucose, which is this one, which I am showing with the help of an arrow. Just see, this configuration matches with what? It matches with D plus glyceraldehyde. So the glucose will be called as D plus glucose. So children, I told you very simple tricks to how to learn the structure of glucose, how to give configuration to glucose. So I hope this point is clear to you. Children, I hope all these points are clear to you. Thank you so much for watching my video. I just want to remind you to subscribe my channel for getting updates regarding further uploads which will be very important for you. Like this video in case you like it and share the video with your friends. Thank you so much. Have a nice day.